Welcome to Science Corner Tutorials. We'll be looking at science concepts in depth. Get ready. Let's get started. Hello guys, welcome to the second video on partial fractions, whereby we are looking at solving partial fractions using the quadratic factor approach. So remember that in the previous video on partial fractions, we used the linear factor approach to solve partial fractions. We're now using the quadratic factor approach to solve partial fractions. We have got to make sure that first of all, we are able to discover or to pick up which method is most appropriate for a given problem. So I explained on the linear factor approach. I'll leave the link in the description box for you to go and see the video, for you to be able to appreciate mathematical problems that needs linear factor approach to put them into partial fractions. So this second video now, we will look at using quadratic factor approach to put given mathematical problems into partial fractions. So when use which mathematical methods now require us to use quadratic factor approach? So when the highest power of the unknown variable, as I've highlighted here, when the highest power of the unknown variable is in the denominator is 2. So remember, if you've got an equation that's x plus 2 equal to y, our unknown variables are x and y, right? So the highest power of the unknown variable of x is 1 here, and the highest power of the unknown variable y is 1, right? Make sure that you understand this. So that's what I mean by unknown variable. So the highest power of the unknown variable of the denominator is supposed to be 2, right? That's how we will be able to pick up that no, we need to use the quadratic factor approach in solving the given partial fractions. So the question will just ask you to say express the following problem into partial fractions. They will not really tell you which method do you have to use. So it's up to you now to decide, and for you to be able to decide, you need to have the knowledge of which methods do we have and which one is used in what circumstances, right? So the first equation that we have here is x plus 2 over x plus 3 in brackets, um, x squared plus 1. So we have got to put this into partial fractions. So the highest power of the unknown variable of the denominator, which is our x here, right, is 2. Please take note. So it means that we are able to use the quadratic factor approach. So the general rule that we use when using the quadratic factor approach is that when we have got x plus, given an equation, right, we say a over x plus 3, right, which is over our denominator, plus bx plus c over x squared plus c. So this is the general rule that we use when we are using quadratic factor approach to solve partial fractions. So if you multiply both sides by the denominator, by this whole denominator here, on the left, on this side, we'll be left with x plus 2. Then on the other side, right, when we multiply a, right, multiplied by x squared plus 3, bracket x squared plus 2 will be left out with x squared plus 1, which is this one, similar to this one here. So for us now to be able to solve and to get our individual terms that we have, which are a, b, and c, which are our known constants that we want to know what is the value that we have got to assign to our unknown constants. We first of all look at our equation here. Then we equate the unknown variable, right? X plus 3, that is the one that is here. We say x plus 3 equal to 0. Then x, it means that it's equals to minus 3. So it means that we've eliminated b and c because we've put minus 3 here, right? It's minus 3 plus 3. We are going to get 0. And if you multiply 0 by bx plus c, we have eliminated bx plus c. So we are now left out with a x squared plus 1, right? Then from there, we now substitute, right? Because we've got our x, which is minus 3. So we substitute on the left-hand side, minus 3 plus 2 equal to a. Where there is x, we substitute with minus 3. So ultimately, we are going to get a equal to negative 1 over 10. So now, after finding that a equal to -1/10, the next step we want to move to is for us to be able to find then b and the other constant c. So remember that initially on the previous page, right, we had x plus 2, which is here. We had x plus 2, right? A bracket x squared plus 1, bx plus c, x plus 3, right? So if we're going to expand this whole problem that we have here, right, we will end up with an expression that looks like this. It will be x plus 2 equal to, we have a bracket x squared plus 1 plus bx plus c, right, bracket x plus 2 plus 3, sorry. Now, if we expand this equation here, we're going to get x plus 2 equal to ax squared plus a plus bx squared plus 3bx plus cx plus 3c. So now for us to be able to move further and solve and get the value of the unknown constant b and c, we have values that have got b on the right hand side, right, and those that have got b on the left hand side. We start with the highest power, which is x squared. So on the left, there is no value that has got highest power of 2. So we're going to have 0 equal to, but we have got this one here, which is a. We've left out x squared plus the other one that has got highest power of x being equal to 2 is b plus b. So that's where we got 0 is equal to a plus b. So from there, we now substitute our a, like what we did here. Then we're going to get our b is equal to 1/10. Now, our constant c, we can now choose, right? Those values, either we choose the one that has got, because x c is on x and also on a constant 3. So if I choose to use it on the constant 3, it's going to be 2, right, equal to the other value here is a, which is a constant, plus 3c. So if we substitute a, we've got it, which is -1/10, right? So if we substitute that one, we will ultimately come up with the value of c being equal to -7/10. 7/10, sorry. Then from there, we will equate our left hand side to our right hand side by simply substituting the values of c and the value of b. And our final answer will be this one. Moving on now to the second example that we have got. It's still the same thing. This is the equation that we have. So the highest power of x in the denominator is 2. Here it means that we can use the quadratic factor approach, right? Then from there, we apply our quadratic factor approach, right? We find the value of a. Ultimately, we also find the a, we also find the value of b and our value of c. Then from there, we simply substitute, and our final answer will be this one. So you can also try and prove to see that if we have done the correct thing. So you now move from this part here going backwards for you to be able to find the original problem that we had. And through that way, you'll be able to see, are you doing the correct thing or you need to modify something.